Okay, let's start. Bismillahir Rahmanir Rahim. Rabbi shrah li sadri yassir li amri wahlul 'uqdatam min lisani. As you know, I'm Dr. Hambacha, PhD Diagnostic Ultrasound Associate. So today we'll talk about attenuation. Uh, as its name indicates and the writing style indicates, reduction in strength of sound wave is called. Do you know about the strength of sound wave? That the power or intensity or strength of sound wave is actually the amplitude of sound wave. If the amplitude of sound wave is greater, then the sound wave will be powerful in their capability to move through a long distance. But if the power of the sound wave is weak, the amplitude is weak, the amplitude is small, then they are weak and uh, Attenuation is actually temperature reduction, right? That's in your usual experience and day-to-day life experiences that sound wave are continuously produced. Whenever sound waves are generated by the source, so with the propagation of this sound wave in the medium, how the event of time when you are going away from the source, the intensity of the sound wave or power of the sound wave is decreasing, and that gradual decreasing actually occur in the amplitude of sound wave. So ultimately, you can say that reduction in amplitude of sound wave is called attenuation. So the unit of attenuation is decibel, right? We have already discussed the unit of decibel, and that unit is actually used for attenuation because it was we discussed about that. The decibel is not the unit of sound, but it is the unit of change. So continuous change is occurring and sound wave in terms of attenuation. So that change will be expressed in the unit of decibel. So actually, we can say that the unit of attenuation is decibel. You know in detail about the unit of the decibel unit, that is a logarithmic scale that is used to express a huge change in a compacted form. So here a couple of examples. You will know about the attenuation, but so by attenuation we mean this is actually reduction. So always actually be negative. So if you use the word attenuation, then there is no need to use a negative sign as well. For example, if there is attenuation in the power of sound wave from 1000 milliwatt to 1 milliwatt, then this change could be expressed in the unit of attenuation, the help of decibel equation. But here, once I want to remind you that you will use 10 law equation for power and intensity and for voltage and amplitude for different law equation. But here this change is occurring in power, that's why I will use 10 law equation and help of 10 law equation. You will see that the ratio is final by initial, and that is 10 by 1000. From 10 by 1000, you'll get log of minus 3, and that minus 3 will be multiplied with the base 10, So this minus 30 decibel represent that there is a reduction in the power, which is minus 30 decibel. But here you can see we are talking about attenuation. That's why there is of, no need to tell that there is reduction because still this minus 30 decibel is 30 decibel attenuation. And so this 30 decibel was written as here are a couple of questions to help clarify. Number first, uh, intensity decrease from 100 milliwatt to 1. Express the attenuation in decibel. Pulse amplitude from 250 Pascal to 125 Pascal. Express this attenuation in decibel and express the attenuation in decibel. Signal voltage changing from 36 microvolt to 9 microvolt. Express this change in decibel. So it was all about these questions and then the answers of these questions, but we have to discuss about them during the guide. So intensity decrease from 100 milliwatt to 1. So the final is smaller number, that is 1. So 1 by 100, and here we are talking about intensities. So we'll use 10 live patient. And the log of 1 by 100 is minus 2. So minus 2 multiplied by 10 is equal to minus 20. So this reduction in intensity will be minus 20 decibel. But if we are talking about the attenuation, then we'll say there is an attenuation of 20 decibel. Right? There is no need for negative signs if you use the word attenuation. Then the other question is pulse amplitude. There is a reduction in amplitude of the pulse from 250 Pascal to 125 Pascal. So this is a reduction by a factor of 2, but this uh, change occur in amplitude. That's why we'll use minus 6 decibel instead of minus 3 decibel. If this reduction with a factor of 2 occur in intensity and power, that will be equal to minus 3 decibel, but reduction in amplitude and voltage by a factor of 2 will be minus 6 decibel. So here it is minus 6 decibel because this change of the amplitude. But if we use the word attenuation with that here is an attenuation amplitude from 250 to 125, then it will be the 6 decibel attenuation. Signal voltage changes from 36 microvolt to 9 microvolt. So again here you can see this is a reduction in signal voltage. But look, this is a change occurring in voltage. And you can see how will we be able to express it in decibel because it is a little bit tough. And I think that it should be included in the exam, right? So if the signal voltage is once reduced by a factor of 2 from 36 to 18 microvolt, so that will be uh, change or reduction by a factor of 2, and that will be equal to 6 decibel because this change is occurring in voltage. So if the signal voltage is reduced from 36 to 18 microvolt, then it will be equal to 12 minus 12 decibel change. Then from 18 microvolt, a second time it was reduced to 9, and so that is also changed by a factor of 2. So there is twofold decrease by a factor of 2 in the signal voltage from 36 to 9 microvolt. And for each reduction by a factor of 2, there will be minus 6 decibel change. So if we have 2 times minus 6 decibel change, then we will add minus 6 and minus 6, and that will be equal to minus 12 decibel. But if we use the word attenuation with that, then there is no need for the negative sign. So if we say that there is an attenuation in the voltage from 36 microvolt to 9 microvolt, then it will be equal to 1 decibel. Right? We'll express it in terms of attenuation as it is 1 decibel. Fariha Jabin is trying to enter the class, so please, it is requested to the co-host. Okay, then you can see these are the answers of these questions. Now we are coming across the mechanism of attenuation, how the attenuation occurs. So attenuation occurs by the mechanism of absorption, reflection, and sketch, right? So first of all, we are coming across the absorption. What is absorption? The conversion of sound energy.
सॉरी सर फॉर इंटरप्शन सर आपकी आवाज़ बहुत ब्रेक हो रही है
अच्छा ब्रेक हो रही है
जी सर
ठीक है करके इस करेंगे absorption is the conversion of sound energy into heat energy. So how we will be able to define heat energy? So actually, heat is the random movement of molecule in a medium. You know, naturally, uh, every medium have the molecule of every medium have its natural moment, but in the case of increasing heat of the medium, the molecular moment is increasing, right? And this is in your usual experience and your common experience that within with while you are heating something, the molecular moment of that medium is increasing. For example, you are preparing tea. It's early in the morning, and all of you should prepare your tea by yourself, right? So whenever you are going to prepare tea, what's going on in the molecule of the water? So initially, the molecule of the water are keeping quiet and calm in the utensil. Whenever you are heating it, so gradually the molecular movement increasing, and a time occurs when the molecular movement increase to such an extent that some of the molecules are escaping the utensil due to increase in the molecular movement with the heat, right? So it's mean that heat is the random movement of molecule in a medium. So again, if we correlate the movement of molecule in a medium, so the Sound energy is also a moment of molecule in a medium, but that is actually a cyclic directional to and fro movement of the molecule with the help of which sound wave can pass through that medium. But the heat energy is actually the random movement of molecule. So sometimes with the propagation of sound waves, the moment of molecule are going in another direction, or they are and converting into haphazard movement, multidirectional movement. So that is actually the conversion of heat energy into the conversion of sound energy into heat energy or absorption. And sometimes whenever you are performing ultrasound of a patient with muscular pain, uh, so sometimes they get relief of the pain, and that is due to increasing the temperature of the muscle. So with increase in the temperature of the muscle or tendon, the stretch is relaxed and the patient feel relief. So with increase uh, and molecular movement of the medium, the heat of the medium or temperature of the medium is increased, and that can reduce the main beam of the sound wave, which is called attenuation. For example, we are talking about main beam. So this is the main beam of sound waves. They are propagating in the medium, and just assume that there are 100 wavelets in this beam, but some of the molecule or some of the wavelets are moving in this direction. Then from here they are moving in this direction. Then they are going to change its path and moving in this direction. So this haphazard movement of the molecule is actually heat energy. But here you can see at this region, if one of the wavelet has gone in other direction, then the main beam is reduced. And if other wavelets are also moving in other direction, then the main beam is reduced. So this reduction in the strength of sound wave is called attenuation. Then reflection. What is reflection? The bouncing back of sound wave from a reflector. So just assume once again that this is a beam, and this beam is reflecting from different reflector placed at different location in the medium. So assume that 100 wavelets are moving in this beam. So the five of the sound wavelets are reflected over here, five reflected over here, five reflected over here, and five over here. So here you can see 20 of the wavelets are reflected until this the location or this position. So if you observe the rest of the beam, so now it will have 80 of these wavelets. So it's mean that the main beam is reduced. So reflection is another phenomena or quality of the sound waves with the help of which the main beam of the sound wave is attenuated. But here in the case of ultrasound, this is very useful. This is actually the reflection quality of the sound wave. With the help of that quality, they are used in the medical diagnosis, because you are transmitting sound waves in the body, they are reflecting back from different reflector look at the different location, and that's why the image of that structure is formed. And that is actually the reflection quality or property of the sound wave, which make them to be used in medicine. Then the other phenomena is scattering. So the help of scattering. Now what is scattering? Whenever sound waves are coming and hitting a small reflector, so they are directing in multiple paths. For example, they can be directed in this direction, and in this direction, and in this direction. But what's the difference between the scattering and heat energy? So in the case of scattering, the direction of the path of the movement is redirected or changed, but now there will be again a directional movement in that very particular path. For example, initially sound waves were coming over here, but now they are scattered and now they are coming in this direction. So this is called scattering. But if you are talking about the main beam, so here you can see this is the main beam, and again you can say that there are 100 wavelets. But some of these wavelets are directed in this direction, but now they are keeping their deviated path. So this is the main difference between the absorption and the scattering, because in the case of absorption, the random movement of molecule is continued, and that is only conversion of sound energy into heat energy. But in the case of scattering, the whenever the sound waves are redirected, then they are maintaining their second path or the lateral path. So they are this is the actually the directional movement of the molecule, but they are not in the direction of the main beam. That's why they are reducing the main beam. So this is a scattering, right? We will discuss this scattering in more detail later on. Then, what are the factors that can affect the attenuation? So mainly there are two factors which affect the attenuation. One is medium and the other one is frequency. Our this session will be ended soon. That's why we have to arrange another session after and this one. The same link will be there. So you will join with the same link, right? So, the medium and the frequency affect the attenuation. Medium affect attenuation by two different methods. On one hand, the different medium attenuate sound wave differently due to the difference in the molecular arrangement, and according to the attenuation, different medium